The Arctic is one of the most rapidly changing regions on the planet, and it's warming about 2 to 3 times faster than the rest of the globe.
There is a lot going on in the Arctic. There are some really significant wildfires happening right now, many of them in Siberia, and we're seeing a tremendous amount of carbon emissions in the region.
Each year, essentially, we keep seeing new record high temperatures being set and new record low sea ice extents. There's been this kind of long-term decline in the sea ice extent over the last 4 decades. Sea ice is this really dynamic type of ice. It's the ice that forms and melts in the Arctic Ocean. So you get new ice forming and melting each year. For about 40 years now, we've been able to actually use satellites to look at the area of the ice on the Arctic Ocean. And one of the things we're noticing from that is when we get to the summer each year, that you get this minimum of sea ice, so it covers the least area of the Arctic Ocean. What we're seeing is that minimum is getting increasingly less over the last 4 decades, and we are losing a large amount of sea ice every year if you look at the trends. And what we saw this year, there's kind of been a heat wave essentially in the Arctic. So temperatures at the North Pole were about 10 to 15 degrees Fahrenheit higher than the average since the 1980s for that time of year. Something that I kind of think about every year now, whenever the sea ice minimum happens, is that the 13 lowest sea ice extents on record have occurred in the past 13 years since 2007. Sea ice is kind of this big protective blanket of bright ice that sits on the Arctic Ocean, and it reflects the sun's heat, it insulates the cool atmosphere from the warmer ocean, and if you start melting away that sea ice, you're going to warm the atmosphere more, and it's going to affect temperature, winds, and weather, not just in the Arctic, but globally as well. The way I kind of think about it is, if you're taking away this big protective blanket from the Arctic, you're essentially doing a massive science experiment almost on the planet. And it's not necessarily an experiment that I would want to see the results of. We are seeing more melt in the Arctic. We are seeing earlier melt and later freeze up. We're combining those with the models that can predict what's going to happen in the future and seeing that perhaps the Arctic is going to become sea ice free sooner than we initially thought. There's a lot of talk, for example, about the temperatures in Siberia and permafrost melting and fires in Siberia, and that's really unusual. And that's because it was so much warmer this year than it has been in, on average, the last 40 years.
Temperatures in the Arctic are increasing 3 times as much as elsewhere in the world. So temperature definitely can play a role in the wildfires that we're seeing there. This year especially has been significant for Siberia in the Russian Arctic, where there's a town up there that's gone over 100 degrees Fahrenheit, and which they never see happen. And also that's the same region where there have been some really significant wildfires, and the smoke from those wildfires can be seen for many miles. But the problem that we're starting to see is that these fires are happening more frequently, and they're more severe than they have been in past decades. We're getting warmer temperatures, drier fuels, and more lightning, which is causing more fires generally in the Arctic year by year. Arctic wildfires happen in these regions that have really thick organic soils. And you say, wait, soil burns? What? Well, it's soil, but it's organic material too. So it's like old leaves and old moss, and it kind of gets compacted and it can really burn. But it's taken tens of thousands of years to develop that soil. And so when it burns, you're releasing a huge amount of carbon into the atmosphere all at once. As a scientist, when I look at these trends, I am concerned, where are we going to go from here? That is why we keep studying this. So NASA has a number of field campaigns that are trying to understand Arctic processes. And I think that it's really important that we keep up this study and try to better understand what is happening and what does that mean for people 50, 100 years down the road.